Now for question 11, we are asked to split this equation basically in the format of partial fractions. And most probably part B would be either to consider that partial fraction and do the binomial expansion, or else to maybe some integration or something like that. These are the kind of, again, some kind of similar questions that you expect in paper 3. So now we are having this kind of format of the algebraic division, where one of the factors in the bottom is having a quadratic factor basically, and one is a linear factor. Then there is a specific way to open this. What are these ways? I can say that f of x is same as writing ax plus b divided by 4 plus x square plus c divided by 1 plus x. Okay? And also we can say that the power of the numerator is less than the power of denominator, and therefore we don't have an extra constant. If it was like, if we had improper fraction where we are getting the numerator and the denominator power are either equal or numerator is greater than denominator, in that case that d would have come. But over here we'll stick with this particular thing and try to solve this particular equation and try to find basically what is the ABC value by comparing it with this particular equation. So over here I can write this thing as, if I just split it into this kind of common denominator. If I try to make a common denominator, ax plus b will be multiplied with 1 plus x, and c will be multiplied with 4 plus x square. C is multiplied with 4. How am I supposed to write this? C and 4 plus x. So this looks good, right? And then divided with the common denominator, that is 4 plus x square and 1 plus x. Now, as you know that this is equivalent to this thing, we can see that the bottom part are equal to, it's just similar. It's just exactly the same. So we can say that the top part, this numerator part, this part is equal to the numerator over here as well. So if we are having that kind of stuff, we can therefore say that, therefore 5x square plus x plus 11 can be compared with the multiplication of this. So that is ax plus b times 11, it's 1 plus x plus c times 4 plus x squared. Now we can just compare the coefficients of x square, x, and constant to find out the values of a, b, and c. So how can we do that? So for that, let me just create this kind of compartment over here. And let me start by saying compare coefficient of x square. So on the left it's 5, and then that is equal to, what is the coefficient of x square if I multiply these two brackets? It's going to be ax into x, so that is ax square. So a from the first bracket, from the second bracket it's cx square, so it's plus c. So that's the first equation that we have got. Second thing that we can do is we can find the, or compare coefficient of x. So if I expand this, on the left it's 1 obviously. On the right, if I expand this bracket, I'll be getting ax term plus bx term, ax term plus bx term. So from the first bracket, I know that a plus b is going to be the output. In the second bracket, I don't have any x term. So that's it. That's my second equation. Lastly, I can compare constants. Compare constants. Or I can just say equate the constant terms, right? But anyway, it will be 11 equal to, in this, the constant is what? Only b times 1, that is the only one constant that we'll be getting. Over here, it is plus 4c. So at the end of the day, we are having this 3 equation to solve. And we know that 3 equations with 3 unknowns, we can easily solve it. So now we can simply go ahead and get rid of all of these things on the left side. We don't require this. And let's try to solve this equation. So what I can do is, I can make a the subject from the first and say that c is equal to, or a is equal to 5 minus c. I can substitute this into this equation, right? So I know that A is equals to 5 minus C from the first equation. From this, I can say that A is equals to 1 minus B. So if I equate them together, I get 5 minus C is equals to 1 minus B. And now this is in format of BC. This is also in the format of BC. I can solve these equations together. So from this, you can say that you got, let's say, I'll just use another pen. Let's say over here you're getting B is equals to 1 minus 5, that is minus 4 plus C. So C minus 4 is what you are getting for B. Now you can substitute this B over here. So this becomes, therefore 11 is equals to C minus 4 plus 4C. So if this 4 goes on left, it becomes 15 is equals to 5C. And from here you got that C is equal to 3. If you got C is equal to 3, you can find A. 5 minus 3 is equal to 2. So you also got A is equal to 2. And lastly, to get B. Now we know that A is equal to 2. So B will be what? B will be 1 minus 2. That is minus 1. So B comes out to be negative 1. Therefore, that's it. You are done with this whole question, except that you have to just write this in the partial fraction format. So f of x is equal to ax plus b, 2x minus 1, divided by 4 plus x squared, and then plus c, that is 3, divided by 1 plus x. So this becomes the final answer of part A. All right. And for sure in part B, we'll be requiring this. We'll either have to expand this kind of thing, or else we'll have to integrate it. Either of the thing could be the possibility. Let's see what is the possibility that we are having for us in this question. Yes, we are having the integration, and in the integration, we have to show that if we integrate this f of x from 0 to 2, answer should come out to be this. And again, it's of 5 marks. Let's try to do this. I'll just shift this part a bit up and also get rid of this end lines and try to integrate this. And therefore, I can just replace it with that. And whenever we have to integrate something like this, let's see if we can take the derivative of the bottom part and we can get that. So derivative of the bottom part is 2x. It is not having minus 1, but it is having 2x. So what can we do is we can split this particular thing into two stuff. So first of all, before even going ahead and do the integration, this can be written as 2x divided by 4 plus x squared, then minus 1 divided by x squared plus 4, and then plus 3 divided by 1 plus x. And now it's easy to integrate like all three of them because it's one step integration. I told you, remember, if you remember the integration rules, everything is simple easy. You get easy marks. All right, so now we are having integration from 0 to 2 of the first bit, that is 2x divided by 4 plus x square dx, plus integration of 0 to 2, or I should say minus, not plus, and that is 1 divided by x square plus 2 square dx. Now it's in the format of 1 divided by x square plus a square. There is a direct formula in the formula booklet, MF19 sheet, if you look into. And then plus 3 times integration from 0 to 2 of 1 divided by 1 plus x dx. That's it. Now we simply have to solve this, and at the end, the answer should come out to this. Let's try to do this. So if we integrate, if we integrate this part, we know that it's in the format of f dash x over f of x. So this answer is ln of the f of x. So ln of 4 plus x squared. And the limits that we have to implement over here are from 0 to 2. Or it's 0 to 2 for everything. So I'll just do it together at the end. And then it's a minus sign over here. Then what is the integration of this? It's tan inverse of x by a, that is 2. And finally, we are having the integration of this. Let's write 3 as it is. And this is again in the format of f dash x over f of x, because we know that derivative of x plus 1 is 1. This can be again written in the format of ln of f of x, that is 1 plus x. That's it. Now we can implement the 0 to 2 limits on top of this and try to see what do we get after this. So if I'm substituting 2 on everything, so 2 square is 4, 4 plus 4 is 8. So we are having ln of 8 minus tan inverse of 2 by 2 is 1 plus 2 plus 1 is 3. So that becomes 3 ln 3 minus, now everything I have to substitute 0. So this is ln 4, then minus tan inverse of 0, and then plus 3 ln 1. Now that's something I have to solve. Here are some of the values that we can straight away know from, from the practice. But even if you're not knowing some things, like what are the direct values, you can use your calci. So what is ln 8? Because we are not going to break ln 8 into decimals, we'll keep it ln 8. But now what about tan inverse of 1? It comes out to be 45 degrees. Or if I keep my calci in radian mode, 45 degrees is what? So it is pi by 4, right? So ln 8 minus pi by 4 plus, now if you see there is no any kind of coefficient in front of ln. So I'll try to bring that on top because of the power rule of ln. So this becomes 3 cube, which is nothing but 27. So 3 ln 27. Then minus ln 4. And what is tan inverse of 0? It is 0. So you don't need to write anything over there. ln 1 is also, if you see in the calc, it is 0. So that's it. This is the final thing that we are going to manipulate it in a way that the final answer comes out to be this. So if I have ln 8, ln 27, and ln 4 like this, I can say the same as writing ln of 8 into 27 divided by 4 minus pi by 2. So let's see what do we get after this. This implies, so 8 into 27 divided by 4 comes out to be ln 54 minus pi by 2. We need to get pi by 8, but we got pi by 2 for some reason. So we must have done some kind of error somewhere. Let's try to see what is the error that we might have done. Oh yes, it's because of this thing. It's because of that. The integration of this thing is not exactly tan inverse of. I mean, it's not tan inverse of x by 2. It's half. It's 1 by a as well, right? We forgot that 1 by a over here. So it's 1 by 2 over here. So this kind of mistakes keeps on happening. Let's that if you were in the examination, if you had this kind of scenario, then you always know that there is something wrong. You cross check it. What's wrong? If your concepts are clear, you will be able to identify what's the mistake. You don't have to get scared like, oh my God, I got it correct answer. I'll have to do everything again. No, try to figure out mistake. And if it's something that you can solve it right away, try to do that. Okay. So over here, this is 1 by 4. And therefore 1 by 2 with this becomes pi by 8. And over here also I did a mistake. Instead of writing pi by 4, I had written pi by 2. It's actually pi by 8 over here now. And therefore this is also pi by 8. So now that becomes your final answer. That's something that we had to prove. Okay. So never get any kind of anxiousness in your examination. Never get scared of this kind of situation. Try to see that how smartly you can solve the error that you might have created. If let's say you are not able to solve it on the spot, but you got the mistake, then you directly go ahead and try to do it in a very quicker way, because now you already know how to do this. You also know what's your mistake. It will hardly take 1 minute to write each and everything once again. All right. So yes, that's the, I guess, end of this whole paper. Let me cross check if there is part C or not. Yes, so that's the end of this paper, and I wish you all the best for your upcoming examinations.